Hello, in this lesson, I'm going to go over shapes of histogram and reading a histogram. Also do a little review about types of variables and level of measurements. Okay, so question number 1. The author surveyed some of the students in one of his statistics classes about the number of hours they work per week. I'm going to keep on here, number of hours worked per week. Their responses are described by the histogram below. Write all answers in a complete sentence and use appropriate units when necessary. Now, this is the histogram over here. The title is Time Spent Working per Week, where the vertical axis, the frequency, and horizontal axis is hours, which is time spent work per week. Now, A, what variable described by the histogram is it discrete or continuous? Now, number of hours worked per week here, time is continuous. Think about it. Between any two time, I can find one between two. So for example, if one student work for 2 hours, another student work 3 hours, I can find someone who work between 2 and 3 hours, 2.5 hours. I can be 2.2 to 5 hours. So for any number you give it to me, I can find time that between any two times. So this is considered continuous. So let's answer the question. So time spent working is my variable, and it's a continuous variable. The variable, okay, I say the variable described here in the histogram is, I'm going to use green, time spent working per week. Working per week, and this is a continuous variable. This is a continuous variable. Part B. What is the level of measurement of the variable described by the histogram? Think about for continuous variable, there are two level of measurement. One is a ratio, one is the interval. Now for ratio, meaning if it is when I do division, it makes sense. For interval, where division doesn't really make sense, right? So for example, I have a student who work maybe 8 hours, another student maybe work 4 hours. Then the first student will work twice as long as the second student. So division here makes sense here. I can say student 1 work twice as many hours as student 2. So therefore the level of measurement here is ratio, right? So ratio. So the level of measurement is ratio. And note that if you can get a little example, you're not sure, you can always say, student who work as, no, let me do a note. Description note. Student work to, a student who work 8 hours is twice longer than a student who work 4 hours. So you're not sure, you can always give the example to see if it's an interval or is it a ratio, right? So this tells me it's a ratio. Part C, how many of the students work between 9 and 25 hours? Okay, 9 and 25, let's look for it. So horizontal here is hour, 9 to 25. 25 is right here. And this is 0 to 5, 5 to 10, 5 to 9, and now 9 to 25 will be here. So again, let's think about how we label histograms. We said to label histogram, we label with lower class limit. So here, notice that from here to here is 0 to 4. From here is 5 to 9, right? And then from here, 5 to 9 is here. And so this one begin at 10 to 14. So if I want 9 to 25, that means I begin at from this is the total number together here. So let's kind of approximate each his bar here, see how tall it is. So the first one here, this one is 4 hours. This one is 1. That one is 2. So I want between 10 and 25. So that means I want this one, and that one, the total of 4 hours. So let's answer the question. So I say 4 students, number of students, right? So 4 students, number of students, work between 9 and 25 hours. Part D. How many of the students work at least 20 hours per week? Keywords at least meaning 20 hours or more. So this means 20 hours or more. Okay, so let's look at my graph. 20 hours or more. Now that, let me use the red now. 20 hours or more, so begin with 20. 20 is the minimum here. 20 or more is mean go this direction. So I would have a student who work a student who work 2 hours. The 2 students here work 20 hours or more. Another student who work 25 hours or more. So that's these 2 over here. So a total of 4 students. Okay, so let's answer the question again. So I'll say 4 students. Okay, 2 plus 2 work at least 20 hours per week. Now, part E, what proportion of the student work less than 10 hours? Again, the keyword proportion. Now, proportion is a number between 0 and 1. You could write in decimal form. The note, the proportion is a number between 0 and 1. It could be 1, it could be 0 too. So that's the proportion. And I want a student who less than 10 hours. Okay, let's go up. Let me erase that again here so I can do. Less than 10 hours, let me highlight it. So 10 hours or less is from here to here. Now notice that student who work 0 to 4 hours is 4 students. No one work between 5 and 9 hours here, so 10 hours. So therefore total only 4 students. But I want proportion. I need to convert that to proportion. So let's put the number on top again to find the total. So this is 1, 2, 2, 2. So there are 2, 4, 5, 6, 10 students in the survey. So in 10 students in this study, therefore 4 out of 10 will be my proportion. That's total 10 students here. Okay, so let's convert the 4 to total. Again, this one is 0 here, nothing here is 0. So let's write it. So I say proportion will be 4 out of 10. In other words, you can write it as 4 over 10. That is 0. That is, wait, is it 10 or 12? Let me double check. So 2, 4, 5, 6, that's 10, that's not 12. All right, so make sure we do it, let me do it correctly here. Yep. All right. So 10, so I can write in fraction, a decimal if I want, or I can just divide it. You can, yeah, again, let's just review how to use a calculator to convert. Just a little review. All right, let me do it. My calculator doesn't want to help here. Okay, it shows up now. So if I want to convert a fraction to a decimal. Now it shows up too many times. Okay, it works now. Okay, so I want to do 4 over 10, so 4 over 10. So any fraction here, you can easily convert it using your calculator. It just, use the little bar in between here tells me division. Okay, so 4 out of 10 is 0.4. Okay, now I'm going to answer the question. Looking for the proportion. A proportion in this class, everything about a decimal. So I would say the proportion of students who work less than 10 hours is 0.4. So notice that I use the keyword, the proportion of students who maybe another word, that work less than 10 hours was 0.4. Okay, let me use the green here, so corresponding to the proportion. Okay, now in question number 2, we're going to describe the shape of a histogram. Now notice that there's A, B, C, D here. I'm going to add 2 more here. I'm going to add, this is called E, let's call this F. All right, so shape a histogram. Now let's look at the first one, A. Notice that an A is somewhat symmetric. If I would cut this in half here, notice that I folded, it somewhat land on each other. Like the fold somewhat equal to each other in a way. Will land on top of each other. So this one is symmetric. Symmetric, also known as a unimodel. Alright, so let's use, or bell shape, another word for it. So let's just say symmetric here. Again, there's a different name for it. Oh, let me write it below. So this is symmetric. You can also say a bell shape. You can also say unimodel. Now, B, notice that B, the tail, if I would draw, notice it's decreasing in this direction here to the left. So it's skewed to the left. So B is skewed to the left. Skewed means skewed left. Okay. Now let's do C. C, notice that if we draw an arrow, notice that it's pointing to the right. So therefore, this is skewed right. Skewed to the right. Now for part D, okay, part D, notice that I have also somewhat symmetric here, because notice that this bar over here, if I would put a bar in the middle, notice my left and right is somewhat equal, one to the right, one to the left. So it's also symmetric, unimodel or bell shape. You can call it either way. Here I'm going to say symmetric. Alright. Now let's look at part E and F that I added into this handout. Now E here, you can tell there's not really any shape to it. Sometimes one up, one down, one up and down. It's somewhat, not really uniform. Uniform meaning the equal height, but here it's kind of random. So part E here is called random. Random, this is no particular shape. It could be up and down and etc. Now for F here, notice that it's somewhat about the same height. Almost all of them approximately had the same height. Not exactly the same, but approximately. So therefore, this one we'll call uniform. Okay, so those are the shape of histograms. Thank you for watching. I will see you next time.